Hello students, welcome to my channel Physics Universal Classes. Okay, today discuss the Newton's laws of motion, students. Okay, this lecture is continued to the previous lecture. The previous video discuss about the introduction of the Newton's laws of motion. Okay, in that lecture discuss about what is the two Newton's laws of motion, first law and second law. Okay, second law in two applications are discussed. First one is the impulse and the second one is the change in momentum, discussed in this previous lecture. Okay, in this lecture the continue to the previous lecture. Okay students, so please listen. Okay, first one problem discuss. First problem, find out acceleration of the block. Find out acceleration of the block. Okay, and this is the block, 5 kg block. The force is acting, 15 Newton force is acting, making an angle 60 degree. Making an angle 60 degree. Then find out in this problem, acceleration find out is a very important problem for JEE mains and NEET level. Okay, first to draw the free body diagram. Okay, the normal force acting in upward direction. Okay, for weight is acting in downward direction. The weight is equal to mass into acceleration due to gravity. The mass is the 5 kg, 5 into g, 5g acting in downward direction. So making an angle 60 degree. Making an angle 60 degree. Okay, in this 60 degree, that force is in this direction force acting 15 Newton is resolved into two components. First one is the horizontal component and the second one is the vertical component. Okay, this is the horizontal, 5g plus 50 cos 60 degree. 50 cos 60 degree, and vertical component is the 50 sin 60 degrees. Sin 60 degrees by using the free body diagram. This normal force is acting upward direction. The weight is acting downward direction, 5 into g, 5g. So making an angle 60 degree. The 60 degree, the angle theta, making angle theta is resolved into two components. First one is the horizontal component, that is f cos theta. Second one is the vertical component, f sin theta. Okay, in this force is 50 cos 60 degrees, horizontal component. Vertical component is the 50 into sin 60 degree. Okay, first to take y direction. Take y direction. The normal force and gravitational force, these two are acting in opposite direction. N is equal to 5g plus 50 cos 60 degrees. 50 cos 60 degrees. N is equal to, okay, g, take g value 10 meter per second. 10 meter per second square. 5 into 10 plus 50 into cos 60. Cos 60 is the cos 60 1 by 2. 2 ones 225. Okay, 5 into 10, 50 plus 25, that is the 75 Newton. The normal force is equal to 75 Newton. Next to take x-axis, this one, take x-axis, x direction, Here F is equal to 50 sine 60, 50 sine 60 degree, 50 into sine 60 root of 3 by 2, 2 ones to 25. Then F is equal to 25 root 3, 25 root 3. Here F is nothing but MA, mass into acceleration, is equal to 25 root 3. Okay, here M is the 5 kg mass, A is equal to 25 root 3 by 5, 5 is 5. Okay, then A is equal to 5 root 3 meter per second square. A is equal to 5 root 3 meter per second square. This is the first problem, students. Okay, it's very important problem for NEET and JEE mains. Find out acceleration of the block. Okay, in this one, free body diagram, in this body, so body is moving on a horizontal surface. Some force is acting, 50 Newton force is acting. So body is moving, two type of forces is acting. The first one, upward force, is the normal force or reaction force or normal reaction. The downward force, the one force is exerted, okay, is attracted towards the earth. That force is called gravitational force. In this gravitational force acting in downward direction, always vertically downward direction, W is equal to mg, weight is equal to mass into acceleration due to gravity. Okay, 5 into 5 kg, M is equal to 5 into G, 5G is acting downward direction. Okay, make an angle theta, the theta is equal to 60 degree. The force is acting in this direction. Okay, in this direction. Okay, this direction. So making an angle 60 degree. Okay, in this 60 degree angle is resolved into two components. First one is the horizontal component, second one is the vertical component. For example, x-axis, y-axis. So making an angle, the first a vector is passing through the origin. That vector is the F bar. The force vector is passing through the origin, making an angle theta. Making angle theta is resolved into two components. So two components is divided. First one is the horizontal component, take F cos theta. In this vertical component is the F sin theta. Okay, in the same manner, 50, that is F is equal to 50. Okay, 50 into cos 60, 50 into cos 60 degree. Vertical component is the 50 into sin 60. First take y direction. Okay, these two forces, upward force, that is the normal force or reaction force, and gravitational force, these two are acting in opposite direction. N is equal to 5G plus 50 cos 60 degrees. Okay, N is equal to 5 into 10 plus 50 into 1 by 2. Okay, 2 ones to 25. Okay, 5 into 10, 50 plus 25, 75 Newton. The next to x direction, F is equal to 50 sine 60. Okay, 50 into root over 3 by 2. F is equal to 25 root 3. Okay, 2 ones to 25. Here F is the Newton's second law. F is equal to MA. MA equal to 25 root 3. Then M is equal to, in this figure, M is equal to 5 kg. 5 is 25. 5 into root 3 meter per second square. Okay, this is the problem, first problem. Continuation, the next to discuss about the force topic. Okay, force and types of forces discuss. Okay, first force. The force means a push, or simply say that a push or pull of a body, that is called force. A push or pull which changes or tends to change the state of rest or of uniform motion or direction of motion is any object. Okay, a push or pull or change tends to change its state of rest or uniform motion and direction of motion of any object is called, simply say that, force. Simply say that force. The force is nothing but a push or pull the which changes tends to changes the state of rest or uniform motion or direction of motion of any object is called force. Simply say that force. Okay, this is the definition oriented for the force topic. Force. The force is the mainly interaction between the object and source. The force is the interaction between the object and source. Okay, this force is defined as a push or pull of a body which changes the state of rest or uniform motion or direction of motion. That is called force. Okay, some effect of resultant forces is there. Some effect of resultant force. Effect of resultant force. First one, so may change only speed. Changes. Second one is the change only direction. Third one, may change both speed and direction. Both speed and direction of motion. Fourth one is the size. Okay, size or shape of a body. Okay, this is the four effects of the resultant force. Okay, first one, only speed. That means for example, a body is at rest position. When a force is acting, that is for example 10 or 20 members people or persons behind the vehicle, then push it. It will be change the speed. At the same time, the direction also changes. And speed and direction of the motion also changes, and size and shape. For example, duff. Okay, taken. Then to change the size. Okay, duff is some only circular shape. Okay, in this one, the force is applied. Then the duff is change size and shape of a body. That is the roti maker. Okay, the roti. That is the fourth point. Size and shape of a body. Okay, this is the four effect of the resultant force. First one is the only speed. May change only speed. The change in the direction of motion. So both change in direction and the speed of the motion of the body. The fourth one is the change in size and shape of a body. Change the size and shape of a body. For example, roti. Okay, this is the force topic. Okay, next discuss about the types of force. Okay, three types of forces. There are basically types of forces. The next concept is types of forces. Okay, in these types of forces, there are basically three types of forces encoded in mechanics. In this mechanics, three types of forces are discuss. First one is the field forces, second one is the contact forces, third one is the hinge force. Three types of forces. First one is the field forces, second one is contact force, third one is hinge force. Hinge force. Okay, these are the classified into three type of forces. So one by one discuss. First one is the field forces. The field forces. Okay, in this, these forces are, these are the forces in which the contact between the objects, these are the forces in which contact between the objects is not necessary, okay. In this field forces means simply say that does not depend on the physically contact, okay, that is the physically, without physically direct contact, that is the field forces are force at a distance. For example, gravitational force is one of the force, attraction force. So between the 2 point masses or 2 point masses. The next to electrostatic force. Electrostatic force is the force of attraction between two type of charges. Okay, this is the simply say that field forces. And in this one, weight of a body comes in this category, that is a weight. W is equal to mg, that is the gravitational force, students. Weight is equal to mass into acceleration due to gravity. Okay, in this force also of field forces. The next contact forces. So contact forces, these are the forces in which the physically direct contact, that forces is called contact forces. For example, frictional force, okay, frictional force, and muscular force also. Okay, muscular force also is an example of contact force. So contact force. Okay, two bodies in contact exert equal and opposite forces on each other. The two bodies in contact, exert and opposite to each other. If the contact is frictionless, the contact force is perpendicular to common surface. That force is called normal force. The frictionless, so one force is acting perpendicular to the surface, that is called normal force. So don't confuse, students. Actually SI unit of force also Newton. That is the symbol also N. Okay, in this I am taking that symbol is normal reaction or reaction force, taking R. Don't confuse, students. Okay, R is the reaction force. The reaction force is perpendicular to the common surface, is acting perpendicular to the common surface, that is called reaction force. And if however the object are in rough contact and have a tendency to move relative to each other without losing contact, then that force is a frictional force. Okay, these two are, okay, for example, a car moving on a smooth road. Okay, tires of the car, the bottom of the tire and this surface, this road, these two are contact with each other. Okay, already discussed in this contact force means physically direct contact. Okay, this is the car tire and this one is the surface. Okay, these two are contact with each other. These two are contact with each other. The force, the applied force acting in forward direction, and frictional force is acting opposite to the applied force. Opposite to the applied force. Okay, in this condition, the normal force acting upward direction, that is the reaction force. The normal reaction is acting upward direction, and a frictional force acting to oppose the relative motion of the body, to oppose the direction of applied force, opposite direction of applied force, that is called the frictional force. Okay, these two are the frictional, again each other exerts a frictional force on the other end. The two forces are equal and opposite. This force is perpendicular to normal reaction. Thus the contact force between two objects is made up of two forces. Okay, since these two are in mutually perpendicular. That is the F is equal to applied force, F is equal to square root of frictional force F square, frictional force square plus reaction square, F square plus R square, F square plus R square. Okay, this is the contact force. In this one is the contact force, students. Okay, in this one, students, for example, the one example contact force. Okay, two objects. So one by one, this is the A, this is the B. Okay, A and B, two blocks. Is lying one by one, like a building type. First F1 force acting. Okay, first in this B, block B is moving forward direction. F1 force acting forward direction. F2 is acting reverse direction. Okay, in this concept, two wooden blocks A and B being rubbed against each other. A is being moved to the left and B is being moved to the right direction. The two are opposite to each other. Okay, in this individually, so taking two blocks individually, so what type of forces are acting? First to take block B. The normal force is acting upward direction. And frictional force is acting to opposite to the applied force, opposite to the direction of applied force. Okay, F1 is acting forward direction and normal force acting upward direction, that is the reaction force R, and frictional force acting opposite to the direction of applied force. Okay, this is the free body diagram of B block. Next to A block. In this one, A. Okay, this is the F2 is the force applied. F2, the force acting in left direction. Body is moving in left direction. The frictional force acting in opposite to direction of the applied force, and normal reaction is acting in downward, because the normal reaction is acting downward because it is the component of contact force perpendicular to the surface. So normal is a dependent force. The normal force is a dependent force. It comes in role when one surface presses the other. That's why the reaction force acting in downward direction. Okay, in this one, students, in this one, the normal force is a dependent force when one surface presses the other. Normal force is a dependent force. So one surface is presses to the another surface. Okay, these two are pressing each other. Normal force is acting forward direction of the block B. Okay, in this block A, the normal reaction is these two bodies are pressing each other. The reaction force is acting downward direction. Okay, this is the contact force. In this one, students, the contact force. So one more example. Attachment to another body. Okay, in this one, tension in a string and spring force F is equal to Kx come in this group. Tensional force and spring force. Okay, these two are acting in this contact force. That what type of forces, students? Tensional forces and spring force. These two are examples of the contact force. One by one discuss, students. Okay, if a string is inextensible, the magnitude of acceleration of any number of masses connected through the string is always same. Okay, in this one is the inextensible. The string is let us consider, take two bodies. First body of mass capital letter M, second body of mass small m is connected with a string. The inextensible string, the magnitude of acceleration of any number of masses connected through the string. So any number of masses connected to the string in this inextensible string. In this block, the horizontal surface is connected by the string, and take pulley also. So pulley manner also. This pulley, small m, capital letter M. Okay, in this case, M greater than M. Okay, acceleration acting in this direction. Okay, in this way, students, so number of blocks are connected in this inextensible string. So number of masses connected through the string. The magnitude of acceleration is same. In this inextensible string, the magnitude of acceleration is same throughout the system. Is a number of blocks, masses of blocks are connected to each other, within a spring. within a string. Okay, in this pulley manner also, in this horizontal surface also, the magnitude of acceleration is same. That is the inextensible string. Inextensible string. Okay, if this is the first one. The second one is, if a string is massless, the string is massless, the tension in it the same everywhere. The string is massless. However, if a string has a mass and it is accelerated, the tension at different points will be different. Okay, the string and pulley are massless, students. This is the black, small m, connected to a string, passed through the pulley. The another end of a string, one black is hanging down. It is the capital letter M. Okay, in this one the string and pulley are massless. The string and pulley are massless. There is no friction between pulley and string. Then there is no friction between pulley and string. The tensional force is acting in the same. The same tensional force is acting. The same tensional force, that is the T, is acting. In this condition is string and pulley. String and pulley are massless. Okay, lightweight. There is no friction. There is no friction is applicable. There is no friction is applicable. Then the time the tension is always same. The tension is always in same at each and every point of the blocks of mass. Okay, this is the second condition. Okay, in the another condition is string is massless but pulley is not massless and frictionless. Okay, if the string is massless, the two type of tensional force is acting. This is the M is connected to a string, passed through a pulley. So another block of mass M is hanging down. The two type of tensional forces is acting. In this one, the tensional force, the T1 is acting. The second body T2 is acting. T2 is acting. Okay, in this one, in this condition is string is massless. String is massless and pulley is not massless. Pulley is not massless and frictionless. This is the another condition. So last one more condition is there. That condition is string and pulley are not massless and there is a friction between pulley and string. Okay, string and pulley massless, but the friction is between pulley and string. Okay, different type of tensions are applied. Different type of tensions is applied. Okay, this is the T1, T2, T3, T4. Different type of tensions are applied. this one string and pulley is not massless, but there is a friction between string and pulley. This is the third application. Okay, in this one, students, contact forces, attachment to another body. First condition is let us consider take two blocks. With any horizontal surface and a pulley manner. The two blocks, the blocks of masses are capital letter M comma small letter R respectively. These two are connected with a string. In this one capital M and small m are connected with a string. The string is inextensible. The same magnitude of acceleration is applicable. Okay, same magnitude of acceleration is applicable. That is the first case. Okay, second case is the three conditions, students. The first condition is the string and pulley are massless. Okay, lightweight. Okay, there is no friction. Okay, these two are massless. Okay, there is no friction between string and pulley. Then at each and every point, the 2 point masses, same tensional force is applicable. Because the string and pulley are massless. There is no friction. That is the condition 1. Next, condition 2, string is massless. Okay, string is massless and pulley is not massless. And frictionless also. Okay, string is massless, but the pulley is not a massless. That is a mass. The mass is considered, students. Okay, two type of tensional force acting. Okay, the two blocks are, one block is attached to the one end of the string and the other is passing through a rope, that is passing through a pulley. So another block of mass capital letter M is hanging down. Okay, two type of tensional forces applicable because pulley is string is massless but pulley is not massless. Then the two type of tensional force is acting, T1 and T2. Then next, third condition, string and pulley is not massless. But there is a friction between string and pulley. Okay, at each and every point, the different type of tensional force are applied. Then T1, T2, T3, T4. 4 types of tensional force is acting. Okay, first of all, so what is the tensional force? So one force is exerted along a thread, rope, string, okay, cable wire, okay, so anywhere, okay, in this, for example, this is the block, okay, is the end. So one end of the block is connected to a string, tied with a string. Okay, in this one, the two type of tensional force. So along the string, the tensional force is applicable. This is the contact force. Contact force. So one more force is there, that is the hinge force. Hinge force. Okay, hinge force. Okay, in this force is the, so for example, in the figure shown there is a hinge force on the rod. Hinge force on the rod, on the rod. So from the hinge, this is the hinge, is the hinge. There are two methods of finding a hinge force, and this one is the rod and this is the string. This is the string. Okay, first one is either you find its horizontal and vertical components. The first one, either you find its horizontal H and vertical components, so vertical components, that is the V. First, either you find out horizontal component or vertically component. The next one is, or you find its magnitude and direction. Magnitude, find out magnitude and direction. Okay, hinge force in this figure. In this figure, there is a hinge force on the rod. From the hinge, there are two methods finding a hinge force. The first one is the horizontal or vertically component, find out. The second, find out magnitude and direction of that force. Okay, this is the hinge force. Okay, now discuss the two applications of the tensional force one by one. Just for example, students, okay, let us consider take a ladder is a contact with ground and wall. Okay, this is the ground surface and this is the wall. Okay, in this the normal reaction on ladder from ground, the normal reaction on ladder from ground, that is the R1 or N1. The next one, from wall, that is the N2 or R2. Okay, two type of normal reactions are applicable in this one. The normal reaction is perpendicular to the common tangent direction and always acts towards the body. It is just like a pressure force. F is equal to PA. Force is equal to pressure into area, which is also perpendicular to the surface and acts towards it. For example, in this one, so the normal reaction on ladder from ground. The normal reaction on ladder from ground is the R1 or N1. Okay, any letter is taken, no problem, R1 or N1. Okay, some students are confused. So because the SI unit of force also Newton N and the normal reaction also N. I will. That's why I am writing two characters R1 and N1. Okay, in this one normal reaction on ladder from ground, that is the R1 or N1. The next one wall, that is the N2 or R2. N2 or R2. Okay, one more example. One more example. So tension in a string. Tension in a string. This block is A. This block is A. One end of the string is connected, is fixed to a block A, is passing through the pulley, P1. This is the pulley P1. Another end is connected to another pulley. Another end of the string is connected to the another pulley. And this one is the P2, the pulley 2. So one block is hanging down, that is the block B. In the other end of the second pulley is connected to, is attached to the ceiling, Okay, in this one students, in this one, the T1 goes to block A. T1 tensional force, the first tensional force is goes to block A. Force applied by string on block A. So T1 goes to block A. T2 and T3 to pulley P1. This is the T2 and T3. Okay, T1 is goes to block A. T2, T3 is a pulley P1, and T4, T5. This is the one tensional force. This is the T4. In this one, T5. In this one, T7. T5, T4, T5, T7. T4, T5, T7 to pulley P2. Okay, in this one, T8 to block B. T8 goes to block B, and T6 to roof. See, T6 is the roof condition. Okay, if string and pulley are massless and there is no friction in the pulleys, these two are string and pulley are massless, there is no frictional force is acting between pulley and string. So already discuss the first two condition for the second application already in this discussed in this previous same lecture. The tensional force are equal, then T1 is equal to T2 is equal to T3 is equal to T4 is equal to T5 is equal to T6 is equal to T7 is equal to T8 at each and every point of the in this figure the tensional force is same because the string and pulley are massless. There is no friction between string and pulley. The first one T1, the tensile force 1, the first tensile force is goes to block A. That is the force is acting on block A. Okay, the next two, T2 and T3, so applied by a pulley P1. The tensile force is applied by pulley P1. The next two, T4, T5, okay, this is the T7, is applied by a pulley P2. T8 is the goes to block B. T6 is the to the roof. Total 8 tensile forces acting, students. Okay, in this one, the string and pulley are massless. String and pulleys are massless. There is no friction between pulley and the string. Then the tensile force each and every point of the pulley and the string, that is the T, equal to T. The tensile force is same. Okay, this is the today lecture. The today lecture only the force concept and types of force discussed, students. Okay, hope you like this video. Please subscribe to my channel for more videos. Thank you. And tomorrow discuss the next lecture is a discuss about a free body diagram. Thank you.